Hello students, we're starting a new 6 weeks, so this first packet is for the first test of the second 6 weeks, and therefore we're calling it Unit 2-1. Okay, we're going to do this first one, and this one is for Friday. It will count on the second 6 weeks though. This is stretching and shrinking, so this is just an extension of the parent functions that we just finished. Again, we did call sometimes you'll see that a compression is called a shrink. So shrinking, another word for that is compression. So stretch and compress. Whoops, I forgot my R there. Press of parent functions. And so when you see the word shrink, that also means compress. So let's first look at the vertical, and we've talked about this before. The vertical stretch and shrink, that's going to be on the outside. So when it's affecting it vertically, it will be on the outside. If the number is bigger than 1, then that's considered a stretch. And if the number is between 0 and 1, then that is considered a shrink or a compress. Okay? So it does exactly what you think it would do. As if the number is big, it gets stretched. If the number is small, then it gets shrunk, or compressed. Now, if you have a horizontal stretch, that's going to be on the inside of your function. Okay, so we just got done talking about translations and reflections that are horizontal and how that's inside, and it's the opposite of what you think. So as the number is big, it's actually going to shrink horizontally. So that means it's going to get closer to the y-axis. So closer to the y-axis. Okay, and then when the number that's being multiplied by b, when that number is between 0 and 1, it's going to stretch horizontally. Okay, which means that it's going to get further from the y-axis. So it's actually going to get farther from the y-axis. Sorry, my handwriting is so messy. Okay, so the one thing I want you to keep in mind is that before completing a horizontal translation, the coefficient on x must be equal to 1. Therefore, if it's not equal to 1, you will have to factor it out to make it equal to 1. So let's look at example 1. First, you're going to write the parent function. So this parent function, because we have a square here, this is the quadratic. And the equation for the parent function of the quadratic is y equals x squared. Okay, let's see what's happening. So it says list the changes with regard to the parent. So everything that is not your parent function you need to say something about. So the 2 is on the outside. This is going to make it stretch vertically. It's really important that you tell me whether it's a vertical stretch or a horizontal stretch. The -3, the -3 on the inside is going to make it move to the right, or so translate right 3, and the -1 or the -1 on the end of it is going to make it move down 1. And since I've already used translate, it's okay to put and, so translate right 3 and down 1. Okay, part C says graph the given function. So start by making your table with your parent function points. So that would have been -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And now what we're going to do is we're going to fill in the other part of my table to figure out where the new points are. So I'm going to look at the outside of my function, which is the 2 and the -1. This is going to affect your y values. So we're going to take 2 and we're going to multiply it by y, and then we're going to subtract 1. Okay? On the inside, that's your minus 3 here. So the minus 3 is going to affect your x values. So we're going to put that over here. And because it moves to the right 3, remember, it's going to be opposite, so that's going to be a plus 3. Because anytime you want to take your x values and move it to the right, you need to add 3 to those values, and that will move it to the right. Okay, so let's go ahead and fill in our new table. So let's start with the x values. Take negative 2 plus 3, that gives you 1. Take negative 1 plus 3, 2. 0 plus 3, 3. 1 plus 3, 4, 2 plus 3, 5. Now let's do your y values. Take 2 and multiply it by 4. That gives you 8, and 8 minus 1 is 7. Take 1, multiply it by 2. That gives you 2, minus 1 is 1. 0 times 2 is 0, minus 1 is negative 1. 1 times 2 is 2. 2 times negative 1 is 1, and it should repeat, so the next one should be a 7. Okay, so let's go ahead and graph this, and let's see if it does what we think it's going to do. So I'm going to graph 1, 7. Which is right here. And then 2, 1. And then 3, negative 1. And then 4, 1. You hear my dog running around with the collar jingle jangling, and then 5, 7. Be right here. Okay, so then now just go ahead and connect your dots, making it a quadratic. Sorry, I missed that 1 point there. Yikes, it's not looking very good. Okay, so here's my quadratic. Best that I could do with using my stylus. And I would always double check it, just make sure. It did stretch vertically. You can see that it's getting narrower if I would have gone through the correct points. Translate right 3, yes it did, and then down 1 it did. Number 2, starting off, this is an absolute value. Whoops, let me pick up my pen, sorry. Absolute value. And the equation for that is y equals the absolute value of x. And what's happening to it? Well, let's start with the negative 1/2. This is going to make it reflect and compress. So if you want to say them separately, let's just say reflect. Which axis is it going to go over? Well, it's going to go over the x-axis. Okay. It's also going to compress because of the 1/2. So it's going to compress vertically. And go ahead and say by 1/2. I don't know if I did on that previous problem, but you do need to tell me how much it's compressing by. And then the -1 on the inside is going to make it move or translate right 1 and translate down 4. Okay, let's go ahead and graph it. So start with your absolute value table. So I'm going to write that over here. My absolute value table takes the absolute value of all the x values. So take -2, which the absolute value of -2 is 2, -1, absolute value is 1, 0, absolute value is 0, 1, absolute value is 1, and 2, absolute value is 2. Okay, now let's write down what affects our x values and what affects our y values. So I'm going to start with the y values, which is coming from the outside. So the -1/2 and the +4. So I'm going to take -1/2 times my y, and then I'm going to add 4 to it. Okay, notice that I'm doing the negative and the 1/2 at the same time, and that's okay because it's going to end up reflecting it and compressing it all at the same time. And then on the inside, that affects our x values, so I'm going to have the -1. But remember, when you write it in your table, it's going to be an x plus 1. Okay, so let's go ahead and figure out what those points are. So if you go -2 plus 1, that gives you -1. Negative 1 plus 1 gives you 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Okay, now let's do the y values. So take a negative half of 2, which gives you negative 1, plus 4, that gives you 3. A negative half of 1 is negative 1/2, plus 4, that gives you a 3.5. 0 times negative 1/2 is 0. 0 plus 4 is 4. 1 times negative half is a negative half, plus 4, that gives you 3.5. And then it should repeat with a 3 here. So let's go ahead and graph that. Negative 1, 3. 0, 3.5. 1, 4. Okay. 2, 3.5. And then 3, 3. Okay, so you can see that it is going to be an upside down V. And if you notice, it did reflect it. It did compress it because it actually got a little bit wider, and it did say it's vertical. And then going right 1, and then, oh, whoops, I'm sorry, I just checked that. I said down 4 originally, but that should actually move up 4. Sorry about that. And see, that's why you should always check your work, because you're going to be able to catch your mistakes. Okay, number 3. So on number 3, hopefully you're recognizing that I've got some horizontal dilations that are occurring, and then I've got a horizontal translation, and then I've also got a vertical translation. So let's write down what our parent function is. The parent function is the square root function. Okay, and normally you won't see that 2 right here by the root. It should just be just a regular square root without the 2. And so the equation is y equals the square root of x. Okay, so now I need to write down what everything is doing. Everything besides my parent function. So I've got this 2 here. Now notice that the 2 has not been factored out yet. So we need to go ahead and factor that out. So I'm going to rewrite it over here. I'm going to have y equals, still have my square root function, but inside that square root function I have to factor out the 2. Just like we did when we were doing reflections, we had to factor out that negative. Well, now I'm going to factor out that 2. So if I take 2x and divide it by 2, I'm left with x. If I take minus 4 and divide it by 2, that's a negative 2, so it's going to be a minus 2. Now this is still under my square root. And then I'm going to have the minus 3 on the outside. Okay? It's very important that you factor out whatever is beside that x. If you don't, then you're going to be writing down the wrong transformations that are happening. So on this one, let's say something about this 2 right here. That 2 is going to make it, remember, it's on the inside, so it's the opposite. So you would normally think that 2 makes it stretch, but this time it's going to compress. And it compresses by the reciprocal, which would be 1/2. Hopefully you remember those activities that we did in class, the discovery activities. So this is a horizontal compression by the reciprocal of 2, which would be 1/2. Okay. It also is going to translate, because it's there a minus 2 there, it's going to go to the right 2. And then the minus 3 is going to make it move down 3. Okay, and let's go ahead and make our table. So the original parent function was the square root, so let's make the square root table. Can't take the square root of negatives, so you're going to start with 0. The square root of 0 is 0. The square root of 1 is 1. And the next one I'm going to choose is 4. The square root of 4 is 2. Okay? Let's go ahead and complete the other side of our table. So what's affecting the y values is the only thing that's on the outside, which is the -3. So I'm going to put y minus 3. The x values, what's affecting the x values is this 2 and then the -2. So again, you write down the opposite. So we're going to take half of x and then we're going to add 2 to make it move to the right. Okay, so let's do that. Half of 0 is 0, and 0 plus 2 is 2. Half of 1 is a half, plus 2 is 2 and a half. And then half of 4 is 2. 2 plus 2 is 4. Okay, on the other side, take 0, subtract 3, you get -3. Take 1 minus 3, you get -2. 2 minus 3 is -1, and now let's graph it. It's going to be at 2, -3. 2 and a half, -2, and 4, -1 would be right here. So if you remember, the square root function starts at a point and then it just kind of goes off to the side here. And hopefully you recognize that it did translate right 2 and down 3. And now let's look at this horizontal compression. You're basically taking your x values and you're pushing them in on the sides. Well, when I push in on this side, this graph is actually going to get taller because it's going to get closer to the y-axis. So it looks like it's doing exactly what it's supposed to do, and so there is my graph. Okay guys, the length of this video is going pretty long, so I want you to try number 4 on your own. So pause the video, press play when you're ready to check your answer. Okay, there was a lot going on with this one. We had pretty much everything that could happen to a function did. So hopefully you got the correct answer. Here is the answer. Okay, number 5, write the logarithmic parent function shrunk vertically by 1/2, reflected over the y-axis, and shifted right 4 and down 3. So first we want to start with our parent function, which is y equals the log of x. Okay, now let's go ahead and start putting in what needs to happen. If it's shrunk vertically by 1/2, that's going to go on the outside. So it's going to be 1/2 of log x. If it's reflected over the y-axis, so think about that for a second, that's going to affect your x values. So that means that it's going to be on the inside with the x. Okay, so I know I'm going to have a parenthesis here with that negative there. Shifted right 4. So after I factor out the negative, if I had a right 4, it would actually be a -4. Because I'm going to go ahead and factor in that negative, then it will be a +4. Okay, and then down 3, that's on the very end, so it'd be -3. So then all you have to do is put your y equals there, and there is your equation. Alright guys, sorry this was a long lesson. I'll try and talk faster next time, but hopefully you got it. See you tomorrow.